What's up, homies? Welcome back. This is lecture 1.3, an introduction to the periodic table. One of my best friends. So let's get to know her, please. Today, we want to focus on creating a periodic table and explaining how atomic number, atomic mass, and periodic trends are illustrated on this table. First things first, we have to know what the periodic table is and what it contains. On the periodic table, we are told a few things. First and foremost, it tells us what the atomic number is, the atomic mass, the element's name, and the element symbol. Now, these two are the most important right here, as you'll be able to read the name anytime you want. However, the atomic mass and atomic number are useful for a wide variety of things, and we'll talk about that right now. First things first, you have to know about the atomic number. Atomic number is important for a couple reasons. One, atomic number tells us the number of protons in the atom. That's all it tells us. As we see here, this arrow is pointing to our number 11, which means that we have exactly 11 protons in the center of our nucleus. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 protons in the center of the atom. Now, sodium is the only element that contains 11 protons. No other element can have an atomic number of 11, meaning that no other element can have 11 protons in the center of its nucleus. Remember that atomic number is the same for all atoms of the same element. So anytime you see a sodium atom, guess what? It's got 11 protons in the center. If it doesn't, it can't be sodium. Cool? Next, we're going to be looking at atomic mass, which is the other number. Now, a good way to differentiate between atomic number and atomic mass is just atomic mass right here. It's not always going to be on the bottom. In most cases, it will be, but it will always be the bigger number. Always. Now, this is something you should probably write down because oftentimes periodic tables will give you different numbers on the top and bottom. So it's important to remember that the bigger number is always atomic mass. Why is the bigger number always atomic mass? Because atomic number tells us the number of protons, and atomic mass tells us the number of protons plus the number of neutrons. Because protons weigh 1, neutrons weigh 1, electrons weigh 0, so the only thing, these are the protons, neutrons, electrons, the only thing that weighs anything in an atom are the protons and the neutrons. So in this case, the bigger number is atomic mass, which is the combination of the number of protons, which weigh 1, and neutrons, which weigh 1. So here's a good example. If I had an atomic number of 13, and I had 1,000 electrons, and I had a mass of, let's say, 23, 23 minus 13 will be 10 neutrons, because electrons, remember, are 0. So it doesn't matter if I have 1,000 of them. They don't add anything to the mass of the atom. And it's impossible to have 1,000 electrons anyway, but that's another story. So remember that atomic mass is the bigger number, and it's the number of protons plus the number of neutrons, essentially the mass of an atom, how much it weighs. The element name and symbol are pretty simple. Every element has a 1-letter or 2-letter symbol. In this case, we have Na, sodium, which actually comes from natrium in Latin. Many of our elemental symbols come from Latin surnames. And so, in this case, if you had something like Na, Cl, you know for sure that Na is one element because the first letter right here is always capitalized. And if the second letter is not capitalized, they're part of the same element. So I can tell that these two are part of the same element. How about these two right here, C and L? That's a lowercase l, so these two are also part of the same element. Now if I were to do something like P, N, O3 or something like this, I know that each of these is a separate element because P is capital, N is capital, and O is capital. So they're all three different elements. Now if it was, let's say, P or CA PS5, this would never exist, but it's a good thing to just make up on the spot. Ca is one element, calcium, which I know because the A that comes after the C is lowercase. The P is one element because it's uppercase, and the one that comes after it is also uppercase. So this is what the periodic table tells us. Constructing a periodic table is very difficult. I would recommend you watch our video on Mendeleev and discover how he first constructed the periodic table. When he organized it by atomic mass, how much they weighed, which is close, but it's not right. Want to know why? Because the periodic table is arranged by atomic number. An atomic number is the number of protons in an atom. And since the number of protons in an atom determines what atom it is, the periodic table is arranged by increasing atomic number. Since you can never have two atoms with the same atomic number. If you have the same atomic number, it means they're the same element. Two elements, they can have the same atomic mass, and sometimes they get really close. But two elements can never have the same atomic number. Never, ever, ever. Because the number of protons determines what kind of atom it is. All right. So I hope this helped, guys. Go ahead and summarize that for me. Great job. You can go on to the next one.